Ngayon naman ay gagamitin natin ang calculator or graphing calculator sa pag-solve ng first and second derivative test ng function para makuha natin yung behavior ng function f using the first and the second derivative. So, umpisahan natin sa problem number 1. We have f of x cubed. At kunin natin yung second derivative. So, ang first derivative or yung critical point sa first derivative at using the calculator, pwede nating makuha yung critical number na f prime of x equal to 0. By using the calculator. So, kunin natin yung function x raised to 3 minus 3x squared plus x minus 2. So, ito ngayon yung ating original function at alam natin, kapag ginraph natin yung original function, pwede natin kunin yung derivative function at kunin yung point of intersection ng ating derivative function along the x-axis para makuha natin yung critical number or kung saan nandun yung relative maximum at relative minimum. So, y equals, kunin natin yung first derivative, math 8, and dx vars, y sub 1. So, ang ginawa natin, ginamit natin yung calculator para kunin yung derivative function at para makuha yung f prime of x equal to 0 o yung critical number, i-equate natin yung y sub 2 sa y sub 3 which is equal to 0. So, ang makikita natin sa graph ngayon, ito yung original function at yung derivative function ngayon is ipapakita ni TI-84 at pag lumabas na yung derivative function, kukunin natin yung point of intersection ng derivative function which is yung parabola opening upwards or represented by the red graph at kukunin natin yung point of intersection nito sa x-axis. And to do that using the TI-84, just press second function, trace, and go to number 5 for intersection. So, kukunin natin yung red graph or yung parabola. So, yun yung first curve natin. At kukunin natin yung point of intersection ng parabola at yung x-axis. So, since ito yung first curve, just push enter at go to the second curve which is the line y equal to 0. At yung calculator na mismo ang magsosolve ng point of intersection niya. So, yung point of intersection ng derivative graph at ng x-axis will be our critical number, yung f prime of x equal to 0, which is 1.816. 1.816. So, mapapansin nyo, dalawa yung points of intersection natin. So, kukunin natin yung point of intersection dun sa kabila. So, to do that, palakihin natin ng konti. So, window, bawasan natin yung x minimum na negative 5. At this one would be 5. Para makita natin yung point of intersection ng susunod na graph. So, yan yung graph ng original function. Ito naman yung graph ng derivative. At yan yung y equals 0. So, nakuha na natin tong point of intersection na to. Kunin naman natin pangalawa. So, second function, trace, go to number 5. So, nasa blue graph siya. So, let's put it on the first curve. So, ngayon yung first curve niya is yung y equal to 0. So, push enter. At yung pangalawa naman, nasa red graph. So, ito yung second graph. So, ilipat natin yung cursor dun sa point of intersection which is dito. At yung TI-84 mismo yung magbibigay sa atin ng point of intersection niya. So, yung isa nating critical number is at 0.186. Now, using the graph, so gamitin natin yung sign chart natin. So, yung critical number natin ngayon ng f prime of x equal to 0 will be at 0.816 at saka 1.816. Titingnan natin yung behavior ng graph from left going to the right. So from yung parabola, makikita nyo nasa positive. So yung second derivative, ang pagbasa ng second derivative natin, yung above the x-axis will be positive and below the x-axis will be negative. So yung above the x-axis, makikita nyo yung parabola o yung derivative graph is nasa positive from negative infinity up until 0.816. So pwede natin siya ilagay dito as positive value. At from this interval naman, nakikita nyo may yung parabola natin is nasa ilalim. So negative yung value ng derivative graph. At from here to here, yung ating derivative graph is positive kasi nasa above the x-axis. Now, since nakita na natin yung sign chart using yung derivative graph, positive, negative, and positive, pwede na natin ngayong isulat yung analysis natin for relative min and relative max. So, F has a low max. S equals 0.816 since F is changing from positive to negative. At yung second critical number natin, yung 1.816, alam natin yung F is changing or yung F has a local min kasi yung F prime natin nag-change from negative to positive. And also, pwede rin nating i-analyze yung behavior ng graph using yung F prime. So alam natin yung F is increasing. So pataas siya. F is increasing. So for all the values that is less than 0.816 or to the left of 0.816 at increasing na naman siya dito sa 1.816, so we can just add it here. So F is increasing dito at saka x greater than. So na-analyze natin yung function F using derivative function gamit ang calculator. Now yung sa second derivative test naman, makukuha natin yung concavity at saka yung point of inflection using the calculator. So, going back to our calculator, so na-plot na natin yung original function, ito yung derivative function, ito yung y equals 0, yung x-axis. Now, para makuha natin yung graph ng second derivative, go to Math 8, x. Now, ang kukunin naman natin is yung first derivative nung y sub 2 para makuha natin yung second derivative ng f of x. So, go to vars, y vars, and y sub 2 para malaman ng calculator na kinukuha natin yung derivative nung y sub 2. So, ngayon, pag nag-graph natin siya, so ito yung graph nung original, ito yung graph nung derivative, ito yung y equals 0, at lalabas na maya-maya yung graph naman nung second derivative. At sa second derivative, alam natin na yung concavity, nade-determine siya kung negative yung value ng second derivative, meron tayong concavity going down. At kung positive naman, yung second derivative, meron tayong concavity going up. So nakikita nyo ngayon, lumalabas na yung third derivative graph. So para makuha natin yung critical number nung second derivative, so let's write it down right here. So f double prime of x equal to 0 para malaman natin kung saan nag-change yung concavity niya. So ito yung second critical set of numbers natin. So ang gagawin lang natin, second function, trace, go to intersect, at kailangan natin kunin yung y-axis. So ito yung y-axis. So ito yung first curve. Yung second curve natin is yung purple curve. So, ito siya. So, yung calculator na magko-compute ng critical number niya. So, kailangan lang natin ng point of intersection ng second derivative at ng y-axis at yung intersection niya is at 1. So, that means yung critical number natin is at 1. So, pag ginamit natin siya, ito yung 1. At mapapansin nyo dito sa graph, so yung positive value again is nasa above the x-axis, negative value is below the x-axis. So, from the left of 1, negative yung value nung f double prime natin. At positive naman yung value to the right of 1. So, sa ngayon, makikita natin na meron tayong concavity going upwards and downwards. So, dito going down, dito going up kasi positive. So, if we're going to write our analysis, yung ating concavity, so F is concave down at x less than 1 since f double prime is negative. At yung pangalawa naman, f is concave up at x greater than 1. So, papunta dito. Ito naman papunta dito. Kasi, yung f double prime is positive. At yung point of inflection natin, it exists at x equal to 1 since f double prime changes from negative to positive. So, ito yung ating complete analysis ng first derivative test using our calculator. At nakuha natin yung analysis natin gamit lang yung TI-84. Now, let's answer the second problem. Magagamit natin to especially sa mga function tulad nito na ayaw natin or mas madali kung gagamitan natin ng calculator. So, let's do the first derivative test. So, f of x is sine squared x plus sine x in the closed intervals 0 and pi. Now, alam natin na yung sine squared x ay parehas lang ng sine x quantity square. At kailangan natin yung notation na to para sa calculator natin. So, let's use the calculator. So, buburahin ko lang si y sub 1 at ipa-plugin ko ngayon yung bago nating function which is yung sine squared x plus sine x. So, ito yung sine squared x. So, ito yung first derivative at ito yung second derivative. We don't need to change anything. Pero, pwede nating i-translate yung graph natin sa 0 to pi. So, we'll go to window. Change natin yung x-axis ng 0 up until pi para makafocus tayo dito sa range of values na to. Kasi ito lang yung interval na kailangan natin para dito sa computation natin. So, push graph. So, ito ngayon yung f of x natin. Yan yung sine squared x plus sine x. At yung red graph naman na nakikita nyo sa calculator nyo, yun naman yung derivative graph. So, kukunin natin yung local min and local max at saka yung increasing and decreasing function by just looking at the red graph. So, makikita natin na meron tayong isang critical number dito kasi yun yung values na nag-intersect si x. So, para mas makita natin, let's go to window. At kukunin natin yung derivative graph na yan. Now, nakikita nyo na rin na lumalabas na yung second derivative graph natin. So, meron tayong original na yung blue graph, yung red graph yung first derivative, at yung second derivative naman natin is yung pink graph. So, ang gagawin natin, since napakadaming graph na nakikita sa calculator, ang kailangan lang natin is yung derivative graph at saka yung y equals 0. Let's turn off yung original function. Let's turn off the second derivative para makafocus tayo dun sa derivative. So, ito na ngayon yung ating derivative graph. Kunin natin yung critical number by getting the point of intersection. Math or second function trace, go to 5. So, ito na yung ating critical number at it's at 1.570 or 1.71. So, yung f prime of x natin equal to 0, which is yung critical number natin, is at x equal to 1.816. So, here, pag gumawa tayo ng sign chart, ito si 1.816. Nakita natin na above the x-axis yung graph natin dito, so it's positive. Below the x-axis, this is negative. So we have relative, so going up and then going down. So we have a relative maximum. At yung increasing and decreasing behavior natin will be determined by the sign of the derivatives. So, f is and f is now, using our second derivative test, so tapos na tayo sa first, makukuha natin yung concavity at saka yung ating point of inflection. So, let's turn off yung derivative function. Now, let's turn on the second derivative function. At ito naman yung second derivative. Kukunin natin yung dalawang critical numbers. Nakita natin meron tayong dalawang critical numbers. So, let's go ahead and go to second function trace. Go to 5. So, yung una nating point of intersection or critical number is at x equal to 2.635. So, yung f double prime of x equal to 0 is our critical number. At yan ay nasa value na 0.635. At yung pangalawa naman, second function trace, is at 2.507. So, sign chart. Dalawa yung intervals natin. One is at 0.635 at 2.507. Now, using yung derivative graph, alam na natin na positive siya to the left of 0.635. So, positive. Negative naman kasi below the x-axis dito sa interval na to at positive dito. So, meron tayo ngayong concavity, concave up here, and concave down over here. So, meron tayong F is concave up at S less than 0.65, S less than 2.46, F is so, F double prime is positive. This time naman, f double prime is negative. At yung ating point of inflection, dalawa yung POIs natin kasi nag-change siya from positive to negative at 6.325. So, POI is at x equals 0.635. At meron din tayong POI dito kasi nag-change siya sa negative to positive. At yan yung pagkuha ng analysis ng first and second derivative test para sa function f using the calculator or yung TI-84.